Yeah, that's 250. We don't want to go there. Yeah. 250 is fun this quarter because we're going to do FPGAs. So it's going to be good. It means we've actually got some boards with programmable devices on them.
Oh, okay.
And there's a new lab, Lab 8, and they're going to program the FPGA to do the traffic light controller. So the wiring consists of 10 wires between that and the test bed. And everything else is done in software through Verilog. So hopefully it'll be a fun lab.
The traffic light was fun, kind of, in a sort of.
In a getting your root canal taken care of kind of way.
Yeah.
Yeah.
I had a lot of fun with that one because it was like our entire class, but one group was trying to do it the worst way possible.
Oh, yeah.
And the one group actually was like, hey guys, if you actually do a truth table, there's this really easy
Mm-hmm.
solution.
Yeah.
And we were all trying to do like from the previous lab, adding to it.
Yeah, and it's a
That's not
little
a good way to
it's a
do
little
it.
weird because we spend all this time talking about state machines and making the big tables and all that, and then we throw that out the window to do the lab right the easy way, right?
It was a good lesson to like, hey, when you actually talk
Yeah.
about this nice way of doing it, maybe you should do it.
Yeah. So for that lab 8, they're going to actually like get to write Verilog version of a state machine, so it'll be a little truer. Yeah, I love the strawberry.
Strawberries good.
All right, so any questions, comments, concerns?
Can you go with
Oh, yeah.
Sorry, I was looking. I didn't see a readme for 305.
There is no 305.
Okay.
Kind of like there is no internet.
You mean that's not the internet?
Yeah, right. Even if it thinks there is. So what the heck were we doing here? Oh, yeah, reading integers from standard in. So an add class, you construct it, it sets a sum to 0. There's a read method that will consume one integer from standard in, add it to a sum, and there's a sum method that returns a running sum. How far did you get on this?
I finished.
Okay.
You finished it, okay. Cool.
Yeah,
I just
I-
want to see if there's any easier way.
I felt like it was a suspiciously simple.
most of the ODPs, if you know the concept that's being tested, they're pretty simple, right? So they're really there to see if you know the concept or not, and if not, you know, to have a chance to figure it out.
I feel like I've spent way too long with us in the add class constructor
Mhm.
with the scanner in front of the SC.
Okay.
I think I spent a little too long with that.
Ah,
and
right.
As such, I never actually got to this point where there was that. So I was initializing it in the add class. So
Right.
it was a local.
Yeah, so there's a scoping issue here. So so running sum, that's a variable defined outside of a method, obviously, because we're going to keep that from call to call. So the constructor initializes that to 0, but then it opens up a scanner, and yeah, we want to save that in a scanner object, but that's got to be declared outside of any method, so that it's a instance variable.
I must have been interpreting the ODP wrong because when it said open a scanner up for reading in the constructor,
Mm-hmm.
I think I interpreted that as I had to declare it.
Oh, okay.
in there.
Yeah.
It's like that doesn't work.
Right.
So.
Yeah, and we'll see this in a lot of classes that we build, right? We'll have objects declared in, you know, as part of the class, but they won't actually get constructed until something happens inside a method somewhere. But if multiple methods are going to access that object, you've got to declare it somewhere where it's going to be basically global to all of those. And we can look at some of the swing code that we've been playing with already and see where that's happening. So yeah, that's the constructor, and then read just calls nextInt and adds that to a running sum, and then sum just returns whatever that running sum is. So that's one way to go about it. I seem to be tapering off on the ODPs. I don't want the ODPs to be busy work, right? Because you've got plenty of work to do with the labs and with the programming assignments. So they may pick up later on, right? Depending on what we're going into. But it's hard to come up with ODPs for like swing, for example, because that's, you know, a whole system level thing. So they seem to be tapering off for now, but they may come back later. Looks like lots of people had trouble actually. Interesting. Other questions? Yeah.
So for PA2, when we're making sure stuff is inserted into the list alphabetically, do you want us to use compare to for that, or what method?
That's probably your best bet, yeah.
So-
Compare to method of string.
Lexicographically or whatever?
Yeah, so alphabetize them according to whatever compare to gives you. So if it's not, you know, something that starts with letters, just take whatever it gives you. So a number sign will come before a 0 and so on and so forth.
So it's okay if capital Z
Comes before little a, absolutely.
Okay.
Yeah. Although, are we converting case?
It doesn't say anything.
I thought I said convert everything to lower.
Yeah, I think you said that.
Yeah, so letters should all be lower. So then they won't come in. Yeah. Yeah. Other questions? I updated Eclipse. Let's see if it works any better. I actually tried installing it like officially, and it's broken. I've already got this running. That's okay. I don't have a mouse. This is going to be bad.
That also was a really tedious fix about the word wrapping issues with the.
Yeah, but once you did it work though?
I was at home by the time I saw it, but that just looks tedious.
Yeah, but once you nail it, you're okay. So yeah,
So
I
is
posted
it
an
one
announcement
time
on this.
thing?
If you're connecting to the Pis from PuTTY using Windows, there seems to be some quirkiness if you resize your window. So I posted a set of things to do. Basically, when you resize, you want to figure out how many rows and columns you have, and then use a pair of Unix commands, reset, and then stty, columns, whatever number, rows, whatever number. And that seems to make them play together well, at least when I tried it in the Collaboratorium.
So do you have to do that again at every?
If you resize.
So if you close out all the PuTTY stuff and then open it back up,
Yeah.
Raspberry Pi, it still works?
Yeah.
Okay.
No, I mean, you have to do it again. But
So every time you're
make
doing
yourself
it-
a profile with whatever number of columns and rows you're happy with.
Okay.
And then in your bash RC, just do your reset and stty.
And you're not able to do that if you maximize it, because I saw you say.
To maximize it, PuTTY doesn't seem to pay attention to the number of rows and columns. So you can count them and do the same thing, but it's a pain.
That's interesting.
Yeah, and like I say, I think it's because both PuTTY and Linux in some sense are trying to manage the window. So when you get to the requisite number of columns that Bash thinks you've got, it's throwing you back to the beginning. And PuTTY is not doing a new line, and yeah, it's just weird. I don't know. It doesn't happen with
It doesn't let me go
Minicom.
back to previous parts of that same line either.
Yeah.
Which is really weird, yeah.
Yeah. And then VI's all over the place, of course, because
Naturally.
I haven't tried playing Rogue on it, but I suspect that would be a nightmare. But yeah, so that seems to work, and like I say, if you set up a profile with a number of rows and columns,
Okay.
then it should be good going forward. Alright, so let's make a Jframe. So we're going to do new, other, and we'll go into Window Builder and Swing Designer in Jframe. And so there's our Jframe. So here's an example of what you discovered with the scanner, right? So content pane is a J panel. It's declared up here, but it's actually created down here. But that's because other things are going to want to access that. All right, so let's see if this will run without crashing. So remember the first thing I said you want to do before you start dropping components?
Get your window space.
Before that, layout managers. So, oh, we didn't get to this, did we? So we dropped buttons, and
Yeah, we saw you drop button.
We just threw a button on there. and
yeah, we
said
threw a
follow
button
it.
on there, and it got really big and goofy looking. All right. So the easiest layout manager to work with, I think, for first cut is an absolute one. So click on absolute layout, come over here, and when you hover, you should get a green plus sign and a green border. Just left click in there. Okay. And over here, you should be able to see layout says absolute. Okay, so let's get rid of this button. So I'm just going to hit the delete key. So now if we take a button and we drop it in here, we can put it anywhere we want. Okay, so we can put it right there. This is button 1, and we can resize it. If I have mouse happiness, right? And we can take another button or text field and drop it here, and we can make that big. Right, and when we run, these things are exactly where we told them to go. And if we change the size of the window, they don't move. And if we make the window small, we suffer from that also.
If you cut the window, like if you actually drag it so it's smaller,
Mm-hmm.
and then you just let go and then bring it back out,
Yeah,
are they
it'll-
still the same, or
yeah.
okay, so they don't.
Yeah, it's just those are placed with absolute coordinates,
Okay.
right? And they're never going to change based on the window size. So it's not the most useful way to lay out widgets, but for first playing with widgets and figuring out how to use them, it's pretty quick and painless, right? But there are lots of other layout managers that will do things like let you position these things relative to each other or relative to the edges of the frame, and then when you change the window, right, things do what they're supposed to do. So a really easy version of that is the spring layout. So you can click spring layout and come in here. And now when I click button 1, I've got these little symbols up here that say where we want to anchor. So let's anchor this to the top, and let's anchor this to the right. And this doesn't always work for me for some reason. So I'm just going to make new buttons. Alright, so this is anchored to the left and the top. And let's put another button in here. And we'll anchor that to the top. And then let's put a text field. And we're going to anchor that to the right. So if I run this, and I've got a window, but those two are anchored to the top, and this text window is anchored to the right. So you can make it respond however makes sense to you for your application. I'm resisting the urge to go get my mouse. So you can change the alignment perhaps. Right, now that button's anchored to the bottom. So I usually stick with absolute layout just for initial purposes. All right. So we want things to happen when you interact with these widgets, right? These components. So buttons are about the easiest to work with. If I double click on a button in this design window, it'll bring me into my code, and it created a bit of a method in here. So it did button new button dot add action listener, and then it's got something like the beginning of a method in here, public void action performed. And here's a spot where I can write whatever I want, and I'm not going to break the window builder component. So let's just do a print message here. Oh, so I learned the shortcut for system out print line. So if you just say syso and control space and then enter, it'll give you system out print line. So I'll just print a message here that says button clicked. And if we run this and we click this button, we get our message. If we click this button, nothing happens because we haven't set up an action listener for this. Okay, but we have a way to respond to that first button click. So I can come to this first button, the second button, and add some code in here. And I'm just going to do a system exit. And over here, I'm going to change the name of this button to say quit. So now if we run this, I lost my window. If we hit new button, it gives us a message saying the button was clicked, and if we hit the quit button, of course, then it just exits. So you can do whatever you want in response to button presses, but basically you're going in and you're adding in Java code. Again, most of which is being written for us. All right, the other way to add, so for buttons, you can just double click the button, it'll bring you into the code. But more generally, if you want to respond to events, you can right click on one of these objects and you can come down and say add event handler. And there's all sorts of different things that you can respond to. So under action, we can respond to action performed, and that varies from component to component. Things that have text, there's caret options, and so caret update, which is when the caret, the cursor, moves. All components we can respond to when they're hidden or moved or resized or shown. So you can set something up to happen when you change the size of your frame, for example. You can automatically run some code that will, do whatever. And let's play around with the key method, or the set of key events. So we can respond to a key being pressed, or a key being released, or a key being typed. Okay, typing is what you usually think of. You press a key and let it go, that's a type, right? But we can also respond just when the key's held down and when it's let go. So let's just do key pressed. And so now I'm in a set of code. There's a method called keyPressed. And this should be called whenever I hit a key inside that text window. So So let's just print a message. And it passes an argument to this called arg0, and it's an object of type key event. And you can go and look at the Java documentation for what a key event is, but if I just start typing arg0 dot, it'll show me all the methods that make sense at this point. And I'm just going to use get key character. All right, let's use key code. So I'll call arg0 dot get key code. And if we run that, and we come inside here, and I start typing, right, I'm getting ASCII codes.
So it doesn't care what key is getting pressed, it just cares that a key was pressed?
Cares that a key was pressed. And if I care about it, if I only want to respond to certain keys, right, that's something I'm going to do inside the code. So I would check the argument, and if it's not a character I care about, I'll beep or something obnoxious and just return. And if I hit backspace, right, I'm getting a key 8. That's the ASCII code for Control H, which is a backspace. If I press the Control key, I get a key code of 17. And either Control key is giving me the same code. If I press a Shift key, I get a key code of 16. I know you can't see that that's what's happening, but there's my Shift key. There's my Alt key. Right, so you're doing more than just reading ASCII codes of characters. You're actually reading the keyboard and seeing what code the keyboard is sending to the OS and ultimately the JVM. I can hit the window key and I get a key code of 524, but of course the window key takes me out of here and brings me to my usual system menu. And there's an escape. What else is there? That's about it for weird ones.
Escape is 27.
Yeah, escape's always 27. That's a standard ASCII. 525 is the weird, I don't even know what the key does. It's a rectangle with little bars in it. It's like the menu key or something. So you can pick up all these keys, right? And arrow keys are whatever those are.
So if you do like Shift A, what is it?
Oh, yeah. So you'll get 2 codes. So I come in here and I hold down Shift and I press A. I get the Shift key plus the key code for A. If I just press an A, I get the same key code.
Oh,
Right? So it's not picking up the fact that it's an uppercase A. Right? 65 is the code for that key with an A on it. And 16 is the code for the Shift. So if you really care about the actual character, we could do get key character. And now if I press an A, I get that. If I hold down Shift, I get a weird character. But if I'm holding down Shift and I press A, I'm getting the uppercase A.
So if you wanted to print a name, you could just get all of the characters out of that.
Yeah, so this is responding to an event. Okay. But we can also hit a slew of methods associated with that text field and see, you know, the whole set of characters that have been typed. So here we'll use our fancy quit button. Bang, here we go. So let's do something different. In VI. I've never used that shortcut before. I've known about it, but I've never used it. Now all of a sudden I'm like in love with it. So thanks for asking about it. All right, so let's, every time that we get a key, let's see what's inside our text field. So our text field is called text field. We could have called it something different. And let's do text field.get, and the first method it offers is get text. And let's put it inside angle brackets. So we won't worry about the key code or anything, we'll just see what the text field is.
Is it possible to get text up to like a space or something like that? Like white space?
Well, we'll read the whole text, but then we could break it up,
Okay.
right?
You could look for an enter, like you could say if the key that was pressed was enter.
Yeah, so
And
then
you
if the
could
key
read
was
all the
pressed, that
text.
was enter, we could do something with the text and then clear out the text field if we want.
Or have a button.
Or have a button for it. So let me do HELLO. And I seem to be one character behind, right? And this is because we're in the key pressed method. So as soon as the key is pressed, we're coming into here, I'm reading what's in the text field and printing it out. But I'm picking that up before that key has actually become part of what's in the text field. So here's 1, 2, 3. And you can see the 3 made it into there, but it didn't show up in our text. So we might use key released or we might use key typed to make it look a little more reasonable. All right, so let's just keep messing with this. So let's add an event handler for key, and let's do key typed. And I'll put the code in there. And this should look pretty normal. Oh, it doesn't. Oh, that's annoying. Oh, because key typed is fired when it's pressed. Okay.
So what would be the difference between typed and pressed in that scenario?
It might have to do with auto repeat. I'm not sure. So let's do key released. This is why I hate touchpads. Okay. So that's a little more what we're expecting.
Why is it firing twice as
Is it?
It is. If you look at the console, you have hello bye
Oh, I do.
twice and then hello bye exclamation point twice.
Did I not comment out the old one? No, I deleted the old one. Good question. Oh, it was because I hit the shift key. Right, so when I release the shift, it's doing a...
Spooky.
Yeah, so you'd want to check for that also. And you can make this as easy or as painful as you choose, right? So, in practice, we would probably look for an enter key, and then we'd pick up the text and do something with it. But if we pick up every single character or every single key press and release, right, we have a great deal of control over what the code's going to do, but we're subject to, all these nuances. Like if you hit and release the shift key 20 times before hitting an actual character, right, you need to deal with that. So let's just do something fun here.
What does the add override do exactly?
Oh, it's letting you know that there is already a key pressed method, but we're making a new version of it.
Oh, okay.
And all these things with @ signs in the front let you customize how the system is responding to this.
So it's like a
So indicates that a method declaration is intended to override a method declaration in a super type. So you can do like @ ignore warnings, and if you're constantly getting a warning about a variable not being used and you don't want to see that, you can override, you can say suppress that warning, because I know that I'm doing that. So there are things that modify how the editor is dealing with your code. And I'm doing something really bad here. I'm hardwiring a magic number, which is 13, but I'll show you how to avoid that. So if the enter key is pressed, let's print out what's in the text field. And then let's set the text to be nothing. So let's play with that. So I can type HELLO and hit enter. Oh, I didn't do that. Guess my enter key is not 13. Well, that's awkward.
How long did you do that?
I can't even stop my code. All right.
It's taken over.
Yeah.
Good, this,
Hit key code.
would you just get the key character and then compare it to the backslash and then?
I could, but now I want to make this work. And it may be a new line versus carriage return issue. So there's ABC. There's my enter key. Yeah, it's a new line. Because I'm on Linux.
Are there, like, numbers assigned to things that aren't on the common keyboard anymore?
Like what?
Well, I'm looking at you like 13. It's like, what if 13 doesn't exist on modern keyboard?
So if you're looking at ASCII codes, right, 13 is a carriage return, 10 is a new line. If you're looking at keyboard codes, I don't have those memorized apparently. But we don't want magic numbers in here anyway,
Yeah.
right? So I'll show you how to do that correctly in a second.
Like,
So there's hello, prints out hello, and it erases the string. All right, so if you want to process text input the way you do from a console usually, right, there's one way to do it. And if you skip all of the false starts, all right, it's pretty short code. So this is a key event. Just go to the documentation and they have things defined in the class for each of the possible keys that you might want. So VK underscore, and there should be a VK underscore enter. Right there. And that should be what you get when you hit the enter key. So that's the proper thing to code inside your method instead of a magic number. And then if you're on a different system with a different keyboard and an enter happens to send some weird character, right, it should match VK enter. So they have these for all the possible keys that you might hit, including things like the arrow keys and so on. All right, so lots of things you can do with text. Okay, so text field entries, you can read the text, you can set the text, you can respond to button presses in various ways. So let's look at mice.
You want to go get your mouse for this one?
Yeah, I know, I should. I'm stubbornly refusing. So I'm inside this content pane. Okay, so let's look at the code a second here. So this whole thing is a class that we're creating. It's called MyFrame. Okay. There's a keyword here, extends. And it says MyFrame extends Jframe. So this we need to talk about more a little later, but this is the idea of a class extension. We've touched on this before. A Jframe is a pre-existing class. It's part of the swing package, and it's got all of this stuff in it, right? And it's got a constructor that will create a frame, okay? Nowhere in this code do I have anything that says, you know, draw a bar, light up these pixels side by side, and then light up these over here, and then this one, and draw a little X up here in a circle. There's no code in here that does that, right? Yet when we construct this frame and we say set visible is true, this window magically appears, right? So where is the code that's doing all of that graphical work, that's doing all of that lighting up of pixels and so on? It's inside the Jframe class. And we're inheriting all of that code because we said my class is extending this other pre-existing class. Okay, in the same way that when we made a rectangle class, that was by default an extension of an object class. An object has a toString method. So if we make a rectangle and we just say, you know, my rectangle.toString, we don't get a compile error. There is a toString method that it inherits from object. Okay, so there is a setVisible method that MyFrame has because it extends Jframe, and Jframe has a setVisible method. So we didn't write the code for setVisible, we're just using code that came from Jframe. And most of what we're going to do in our MyFrame is stuff that's already inherited from Jframe, right? So we're reusing all of this code that's already available to us, but we can make some changes. For example, we can say, I want to create a button, and I want to drop it into a content pane. And so on. So we can say, let's add a content pane to our Jframe, and so on. All right, so MyFrame is the outside frame. Content pane is an instance of what's called a JPanel. And a JPanel, you can think of it as a container. It's a thing that you can put other widgets into. And if you come over here to the design window, all right, this is the Jframe. I got to it by clicking on the top bar, but and over here it's telling me what the class of that object is. So it's a Jframe. But over here, this is a content pane. Okay, and it's class JPanel. So content panes come with a variety of event handlers. So I can right click in here. Please tell me I can right click. I crashed. Ooh. Yeah, I can, but I can't click on
Are you
things.
able to scroll in there, or is that just?
Okay, yeah.
I mean, I can move
Yeah.
the scroll bar, but I'm not scrolling. So I'm gonna have to try like a different version of Eclipse, because this is annoying. I'll have to try spelling it right too. So a content pane has event handlers that we can specify. We can pick up keystrokes. We can also pick up mouse events. And that's going to be the most useful one in the short term. So let's look at that. So I'm going to right click in here. Oh man, I'm not happy. I'm going to say add event handler, and let's come down to mouse. So we can respond again to mouse clicks, mouse presses, and mouse releases. Okay, so a click is a press release event. Press is just press, release is letting go. We can also respond to when the mouse enters this component and when it leaves. And if you want to learn this stuff, the best way to do it is just to play with this, right? Go into each of these event handlers and put in a print message and figure out what these things are doing. So let's do a bit of that. So there's our mouse clicked. And let's just do a mouse leaved. Mouse exited. So let's run this. So I put the mouse in there. If I click, I'll get a message saying that I clicked. As soon as I leave that window, I get a message saying the mouse exited that window.
It doesn't tell you when it's due.
But I didn't put anything in the entered.
Okay.
But if I enter and I exit again, it'll tell me that it exited. Right? And that's kind of useful.
And it'll log in policy for you.
Yeah, if you leave. Let's go ahead and do entered. So now we'll get both of those.
It's overwriting.
I don't know. I'm
It's
seriously killing my system though. Doesn't want me to enter. Okay, there we're inside and there we're leaving. All right. This is nice because I don't even have to click in here. But if I do, I'll pick that up also. And so it's telling me that I clicked when I release. And so on. And it should be touchscreen friendly also. All right, so let's touch on one more.
So just a random thought.
Yeah.
Are you able to store a mouse position when you, like where exactly the mouse is?
Yes.
In the window, and then
Yeah.
like pick up a new mouse position if it like say you want to drag your mouse.
So there's a whole separate list of these things for mouse motion. So we can call a piece of code when the mouse moves or when you're dragging the mouse, dragging something with the mouse. We can get mouse position from there. But we can also get information about the mouse clicks. So these are mouse events. So mouse events, we can say get button, and it'll tell us which button was clicked. Get the number of clicks associated with this. We can get the location on screen, so we can find out where you are in absolute coordinates, so not relative to your frame, but relative to the actual display of your system. We can get the XY coordinates relative to the source component, so inside the J panel, we can see where you clicked. And those are probably the main things. And when you get a button, right, we can use these fields, button 1, button 2, button 3, and so on. So no magic numbers. And for the type of event, we can use these fields, mouse clicked, mouse dragged, and so on. But let's do mouse clicked. Let's just print out arg0. So every time we do a mouse click, let's see what information we get. So we've got coordinates, we've got absolute coordinates, and button 1 is going to mean it was a left button. And you can get modifiers, so if you hold down shift and press a button, you can find out what keys were pressed, and so on and so forth. But those methods in mouse event will break those out for you. All right, I've totally munged my code at this point because of my bad touchpad mousing skills. But that's a good place to call it quits here. So, so I will have a mouse with me tomorrow, and tomorrow I just want to go through some of these components, check boxes, radio boxes, spinners, things like that, and just give you an idea. But again, the way to learn these things is not for me to sort of tell you about them. The way to learn them is really just start writing some code. Drop a J spinner, go to the actions that you can associate with that, write some code in there and figure it out, or worst case, read the documentation. But it's more fun to play with them. But I want to go through enough of them to give you an idea of some of the basic types of events and handlers that we can set up, and then let you go off on your own. All right, I'm going to put this thing out of its misery. Okay.
You can type things in the console, even when it's loop, and it also does not acknowledge